Hello everyone, myself Bhavani, Assistant Professor in IT Department at SMIT. Now we're going to see about the AIML, Artificial Intelligence and Machine Learning. Subject code will be CS3491. Okay. Local search algorithm. It focuses on current state only. It does not keep track of paths. Suitable for optimization problems. Uses minimal memory. Can get stuck in local maxima. Fast for large state spaces. Example, hill climbing, useful in scheduling problems. Optimization problems, it seeks the best solution. Objective functions measures quality, constraints limit valid solution. Local search is commonly used. Local optimum is desired. Local optimum may mislead search. Simulated annealing help escape traps. Used in resource allocation. Advisor search. It involves multiple agents. Agents have conflicting goals, common in game playing. Each agent tries to maximize its utility, often an attempt to minimize it, assumes rational opponent. Game trees represent choices used in chess and tic-tac-toe games. Maxi, min, and max algorithm. Minimax algorithm, nothing but used in advisory games. Players alternate between maximum and minimum. Game tree is explored. Terminal states have utility values. Maximum players chooses highest value, minimum players chooses the lowest value. Guarantees optimal play, computationally expensive. Alpha beta pruning. Alpha beta pruning improves minimax. It removes unnecessary branches, reduce computational timing, does not affect final decision. Alpha represent best maximum values, beta represent best minimum value. Pruning occurs when alpha greater than or equal to beta enables deeper search. Alpha beta pruning is an optimization technique used for minimax algorithm used in game playing like chess, checkers, tic-tac-toe games and all. It reduces the number of nodes evaluated in the game tree without changing the final decision. Actually, we need to know why you're going to choose about the alpha beta pruning. The minimax algorithm explores all possible moves, which is computationally expensive. Alpha beta pruning eliminates branches that cannot influence the final outcome, making the search faster. Key term alpha and beta. Alpha, let it be the best maximum value that the maximum player can guarantee so far. Beta, the best minimum value that many players can guarantee so far. Basic idea, nothing but maximum tries to maximize the scores. Minimize tries to minimize the scores. If at any point alpha greater than or equal to beta, further explosion of that branch is stopped, pruned. This is because the current player already has a better option elsewhere. Algorithm, nothing but start with the root node with alpha minus infinity to the beta plus infinity. Recursively apply minimax, update alpha at maximum nodes and update beta at minimum nodes. Okay. Actually pruning a branch between the alpha greater than or equal to beta. Okay. In alpha beta pruning we have pseudocodes also. Please check into it. Let a conceptual example, let it be maximum finds a move with value 8. Minimum at least sees a branches where the best outcome is less than or equal to 5. Since minimum will avoid worse outcomes, the branches is pruned. Advantages of alpha beta pruning will be reduces the time complexity, allows deeper search in the same time, produces same result as the minimum and maximum. So there will be time complexity, with both cases, worst case and then best case. Okay. Application will be same: chess, tic-tac-toe, checkers, connect for game die engines. Next, constant satisfaction problem. It involves the variables and constants. Each variable has a domain. Constraints restricts variable values. Goal is to satisfy all constraints. Solution assign value to variables. They are well-structured problems used in scheduling and planning. Example includes Sudoku game. Okay, CSP representation. It's nothing but constraint satisfaction problem representation. It's represented using variables. A domain specify for possible values. Constraints define relationships. Constants graph shows dependency. Unary constants involve single variable. Binary constants involve two variables. Higher order constants involve many. And then efficient order constraint involve many. Efficient representation improves solving. Okay. Same CSP solving techniques. Backtracking search is commonly used. Forward checking reduces domain early, or consistently ensures constant satisfaction. Heuristics improve variable selection. Constant propagation reduces search space. Reduce time complexity. Improves efficiency, and used in real world problems. These are the solving techniques for CSP. Thank you.